within them, right? 1. Now if you look at the last two digits, this is the typical carbon percentage range. That's the medium. So it can be from 0.5 to 115, 10 to 20. So you see his 10's right in the center, 15's in the center of this. Okay? I want you to look through that in your book, understand the major alloying elements, specifically what type of steel it is, and then also that the last two digits mean the percentage of carbon as well. Okay? Types of cast iron. Trying to figure out where in our book we are. Sorry. We're on page 1 or page 97. Page 97 talks about the different types of cast irons. Okay, the next couple pages goes through. We're going to flip to page 100 in the book, and I want you to highlight each one of the different types of cast iron. So iron-based materials contains 91 to 94% iron. Look at the carbon percentage is really high, 2 to 4%. It can't be formed by forging, rolling, drawing, bending, or spinning. Low ductility, a lack of malleability, very brittle, very heavy, very hard. Castings have low ductility, low tensile strength, excellent compression strength, which is why we use them on such things like railroad tracks. The lower carbon percentage anyway. Perlite is a good combination of both. But like a cast iron anvil, you know, we can bang on it, so forth. 4 classes: gray, white, nodular, and malleable. Those are the 4 pieces that we want to talk about. Now they each have their own strengths and weaknesses as well. Gray iron first, low in ductility, moderate tensile strength. It can be fusion welded or brazed together, preheated. There's some special cast iron rods out there too, like a Nicolai 55 and so forth. You can use along to weld it up. White iron, produced through process of rapid cooling, which causes carbon to combine with the iron. Very hard, very brittle, difficult to machine. It's considered to be unweldable, fine grain structure, and so forth. If you notice, gray iron's got quite a bit of good possibilities there. You can machine it. It's got good compression strength, moderate tensile strength, and low in ductility though. But you know, we know that it's got quite a bit of carbon in it to begin with. Malleable iron forms when white iron has been heat treated by long annealing process, so you gain tensile strength, impact strength, and toughness. Than gray or white iron. So right here's a really good option. You can use fusion welding with it. You can do braze welding. You can't use fusion welding, I'm sorry. It says it destroys properties in the welding. So brazing is the method you would want to use with malleable iron. If broken, the fracture shows white rim with a dark center. Nodular iron is a ductile iron. Most people call it ductile iron, not nodular iron. It's good machinability, shock resistance, wear resistance, and rigidity. Okay, let's talk about aluminum. World's largest producers of aluminum, more than 22 million pounds of metal processed annually. We're on page 101. You can see the designations for aluminum alloying groups on the top side. So looking at the 1000, on the right hand side you see the designation, left hand side you see the major alloying element. Okay, same thing. So the 1000 series is aluminum, copper is the 2000 series, manganese 3, silicon is 4000 series. You get down here to the 6 and magnesium and silicon, so forth. Okay. Types of aluminum. Reading from the book, I'm going to read through this paragraph. A 4-digit numbering system is used to identify pure aluminum and wrought iron aluminums. The first digit indicates the major alloying group. For example, the 1000 series identifies an aluminum that is at least 99% pure. 2000 is aluminum with copper as the major alloying element. 3 categories of aluminum that find the most welding applications are commercially pure aluminum, wrought aluminum alloys, and aluminum casting alloys. So let's read each one of the bulleted items. I would highlight them as well. Commercially pure wrought aluminum, 99% pure, easily welded. Welds have strengths equal to the material being welded. We back up. There are several different applications within the uses of aluminum here. I'm on the PowerPoint now, I'm sorry. Read through these on your own. Now we're back to the types of aluminum here. 3 categories of aluminum find most welding applications. Let's talk about it on the PowerPoint, as long as you've highlighted it in your book, the bulleted items. Commercially pure, 99% pure, little iron and silicon, easily welded, good strength equal to the base metal. Wrought aluminum, 1.2% manganese, 97% aluminum, stronger than the 1100 type and less ductile, weld without difficulty, and weld strong. Aluminum, silicon, magnesium, chromium alloy, classification number of a 6151. Welds are not as strong as the base metal, can be improved by heat treatment of them as well. Usually the 6000 series is what you'll see on like road signs because of good corrosion resistance and strength. Okay. The aluminum, magnesium, chromium alloy, 5052, strong, highly resistant to corrosion, good ductility. Let's go down to 6053, the aluminum silicon, magnesium silicon alloy, readily welded and can be heat treated. So if you're doing a lot of production stuff with aluminum that you would need to do some crazy welds on, or you would have to weld something onto it and instead of just casting it, then 6053 might be more what you're looking for than the 6151. Okay. Titanium making, it's a versatile metal, lightweight, physical properties, good mechanical properties, produced from heavy mineral sands containing ilmenite and or rutile. Also titaniferous slags made by smelting of ilmenite with carbon. Most of this stuff you or I have never heard of. I've heard of titanium a lot, but some of the chemical elements within it, can be quite confusing at once. So feel free to read through the titanium section as well on your own. You know, the greatest thing about the titanium is the medical use of titanium products today. Very good corrosion resistance, very lightweight. the CTEs, the coefficient thermal expansions, half that is stainless and copper, 1/3 of aluminum. Great impact properties. Modulus elasticity is half that of stainless steel. Just a really good material, but fairly expensive as well. Here's a good example. The corrosion rates in comparison. All right, let's get to types of distortion. Page 105. Two major aspects of contraction in all types of welding: distortion and stress. Distortion can also be called shrinkage. Okay. Usually means the overall motion of parts being welded, or from the position occupied before welding to that occupied after welding. Okay, so before welding it was nice and flat. After it was welded, the weld contracted. It created stress and shrinkage within there, also resulting in distortion. Stress, on the other hand, is a force that will cause distortion later unless it is relieved. So, real quick, I thought they had a better picture in here. There's internal stresses within this weld bead. Due to the stresses, that's what helped cause the distortion, okay? If we were to stress relieve it, it wouldn't necessarily go back down 100%, but sometimes it will, okay? Bring it in, you anneal it, stress relieve it, bring it up to 1200 degrees, cool it off nice and slow. The stress within this weld is not going to get any worse. It's not going to pull and draw more. If anything, it'll just stay where it is, and more than likely it's going to slightly come back down some, less, creating a little bit less distortion as well. Okay, there are plenty of other things in the rest of this chapter to go over. However, I know this is a very long chapter. Please take your time doing sections one at a time, going through it. We've talked to you about neutral axis of the joint before, other chapters. We've talked a lot about transverse contractions, tack welds, other things. Okay? Feel free to look through this PowerPoint slide, ask any questions, so forth. But at this point, I do want to talk about this. This is one common way to sometimes just to control distortion, okay? So what you're seeing here is one way to control it. If we just started here and we started welding and we're putting just a lot of heat in there and the whole thing's just kind of warp up, okay? But if we did, so right here what it's telling us is go from B to A. So we go here, then we're going to come back down here, we're going to weld here, and then we're going to weld here, and then weld here. We're going to stagger it, backstep it. And maybe not even just in this direction, but maybe we'll come back a different direction. We might weld here to here, here to here, and then go this direction. Start here and pull this way, okay? We're going to stagger our steps, and that will help control distortion as well. Okay, that's where I'm finishing this PowerPoint. Feel free to read through the rest. Take your time, look through this, this entire chapter, especially in the book and the tables. There's a lot of information in here to learn. This is just the basics of welding metallurgy. We can get a lot more advanced. However, today, this chapter, I mainly wanted to focus on a broad overview. Good luck. Come see me about any questions you have. Thank you.